partial fraction decomposition of the rational expression p over q in lowest terms depends on the factors of the denominator q itself. This means that the denominator q of the rational expression p over q will contain only factors of one or both of the following types. It could be a linear factor of the form x minus a, where a is a real number, or it could be irreducible quadratic factors of the form ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Irreducible just means it cannot be factored down, that it's prime. So we're going to go through one example of a non-repeated irreducible quadratic factor and a repeated irreducible quadratic factor. So here is our first rational expression, 1 over x times x squared plus 1. So we have a linear factor x and an irreducible quadratic factor x squared plus 1. X squared plus 1 cannot be factored, so it's irreducible. So we have 1 over x squared plus 1. And since we have two factors, we will have two fractions. This one being x, and this one being x squared plus 1. Now this is a linear factor, so its top number is going to be some constant a. And this is an irreducible quadratic factor, so its top is actually going to be a linear factor. So it's going to be bx plus c. It's always going to be one less than the denominator. And now we're going to find the LCD, which is not too hard because it's just going to be what we factored here, which is going to be x squared plus 1. So we will multiply the entire equation by the LCD. When we do that, we're going to end up getting 1 equals a x squared plus 1 plus bx plus c times x. And since we're dealing with some quadratic factors, I'm just going to equate coefficients. So I'm going to distribute the a and the x across, and I'm going to get 1 equals ax squared plus a plus bx squared plus cx. And so the highest exponent here is a 2, so I'm going to find out all the coefficients for x squared. So on the left, there are none, so I say it's 0 equals, and all the coefficients of x squared are a and b, so a plus b. So done with those two. And now next is going to be the factors of x, or the coefficients of x, excuse me, so x to the first. So again, there's no x over here, so we say it's 0. And over here on the right side, it's just c. So that one's done as well. And now, just the constant terms, x to the 0. On the left, there's a 1. And on the right, there's just a. So right off the bat, a and c have already been figured out. So now all I gotta do is figure out b. So I can take what a is into this equation and solve. So I'm going to get 0 equals 1 plus b. And then solve for b, I'm going to get negative 1. So now I have a, b, and c. So I'm going to go back up here and replace a, b, and c with what I know they are. So I'm going to get 1 over x plus negative x over x squared plus 1. Because plus 0, no real need to write it in, so I can just write it as negative x. And here is my partial fraction decomposition for the original expression. Now I'm going to go on to the next one, and we have x squared plus 2x plus 3 over x squared plus 4 all squared. So this denominator is not factorable, and it is repeated. So x squared plus 2x plus 3 divided by x squared plus 4 all squared. So we'll have two fractions because we have two terms. This is going to be the x squared plus 4, and this will be the x squared plus 4 all squared because it's repeated. And since they are both quadratic factors, the tops will be 1 degree less. They will be linear factors. So ax plus b and cx plus d. And now we're going to multiply everything by the LCD, which is just going to be x squared plus 4 all squared. So I will multiply the entire equation by the LCD. And when I do that, I will get x squared plus 2x plus 3 equals ax plus b times x squared plus 4 plus cx plus d. And again, I'm going to equate coefficients so I can figure out my a, b, c, and d. So I will distribute the factors here, and I will end up getting x squared plus 2x plus 3 equals ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. And now time to equate coefficients. My highest degree here is a 3, so I'm going to start there at x cubed. So the coefficients of x cubed on the left side are 0. And on the right side it's just a. So that one's done. Next is x squared. I have a 1 coefficient over here. And I have a b on the right side. And that's it. Next is x to the first. And I have a 2 on the left side. And on the right side I have a 4a. And I have a c. And finally my constant terms, x to the 0. I have a 3 here. And on the right I have 4b plus d. So now I have two answers already, a being 0 and b being 1. Now I got to find c and d. So if I plug in 0 for a, I'm going to end up getting 2 equals 4 times 0 plus c, which is going to be 2 equals c. So easy enough. There's c. And now I'm going to find out d by plugging 1 in for b on the fourth one. So 3 equals 4 times 1 plus d. So 3 equals 4 plus d. Subtract the 4 over. That should be a d, not a b. Excuse me. So subtract 4 over, I get negative 1 equals d. So now I have a, b, and c and d. 0, 1, 2, and negative 1. So now I'm going to go back up to my original, or this one right up here, and I'm just going to replace a, b, and c and d. So a is 0, so I don't really need to do anything, but b is 1, so I'm going to have 1 over x squared plus 4 plus c is 2 and d is negative 1, so 2x minus 1 over x squared plus 4 all squared. And this will be my partial fraction decomposition of the original expression.